In this video, we're going to begin by proving that the variance of a random variable, which is defined as the average square of the deviation of the observations away from the expected value, or the expected deviation of the observations away from the expected value, is the same as the expectation of x squared minus the expectation of x all squared. So, in order to analyse this, let's just start by writing down the definition of the variance, which is the expected value of x minus e of x squared. Now we're going to begin by squaring the brackets inside the expectation. So we can rewrite this as being equal to the expectation of squaring inside the brackets. We're going to get an x squared term. We're going to have an x multiplied by e of x term, or minus x times by e of x term. So that's minus x times by e of x. Then we're also going to have a plus e of x all squared term. And then another minus x e of x term. Now, in order to analyse this, we need to use a few rules relating to expectations. And we know, for instance, that the expectation of a sum of random variables is equal to the sum of the expectations. So we can break the variance formula that we've got down into four parts. We can break it down into the expectation of x squared. We can break it down into the expectation of x times by e of x, plus the expectation of x all squared, minus the expectation of x times by e of x. Now, the expectation of x is just a constant, and similarly the expectation of x all squared is just a constant, and the expectation of any constant is just going to be equal to that constant. So in this term, the first expectation term can just disappear. So what other rules do we have about expectations? Well, we also know that the expectation of any constant times by a random variable is equal to that constant times by the expectation of x. And then we've got a constant e of x included within expectation, so we can take those outside of our expectations. So we can rewrite this as being the expectation of x squared minus the expectation of x times by e of x. E of x is a constant, so that can come outside of the expectation. So that's minus e of x times by e of x. Then we've got plus the expectation of x all squared, minus, and then just the same, the expectation of x comes out, the expectation of x times by the expectation of x. But these terms here, this one and this one, are just the same as the expectation of x all squared. So we've got the expectation of x squared minus the expectation of x all squared plus the expectation of x all squared minus the expectation of x all squared. So two of those cancel, just leaving us with this is equal to the expectation of x squared minus the expectation of x all squared. Now, linked to this, we might also be interested in analysing the covariance between x and y. We're going to use exactly the same methodology as we did before, and we're going to begin by multiplying out the brackets inside the initial expectation. So we can write that the expectation of x minus e of x, y minus e of y, is just equal to the expectation of xy minus the expectation of x times by y minus the expectation of y times by x plus the expectation of x times by the expectation of y. Now we're going to use exactly the same rules as we did earlier. So we can rewrite our expectation of our four terms as being the sum of expectations. So it's going to be equal to the expectation of xy minus the expectation of x multiplied by y minus the expectation of y times by x plus the expectation of x times by the expectation of y. And again, just as before, expectation of x and expectation of y are constants, so they can come outside of our expectations. And this term here, the expectation of x times by the expectation of y, is just a constant, so the expectation term at the beginning can just vanish. So we can rewrite this as being equal to the expectation of xy minus the expectation of x times by the expectation of y minus the expectation of x times by the expectation of y plus the expectation of x times by the expectation of y, and two of these terms cancel, just leaving us with the covariance between x and y is just equal to the expectation of xy minus the expectation of x times by the expectation of y. So because of these, we can simply write, if we want to calculate either the variance of x, this is just the same as the expectation of x squared minus the expectation of x all squared, and the covariance between x and y is equal to the expectation of xy minus the expectation of x times by the expectation of y.